All right, welcome back. I have a beautiful warm-up for you. This is again Mr. Fincher. We will be working through polar graphs today, but we need to make sure we have our confidence level high for polar coordinates and rectangular coordinates. So take about 5 minutes to work through these 8 questions. And pause your video and now. All right, your final answer for each of these, I'm just going to quickly write up. Number 2 should be 5 over 2, negative 5 root 3 over 2. Number 3 should be 0, 1. And number 4 is the only one that you have to give, well, I kind of gave it, it says exact, except for number 4. Never mind. So the approximate value is this 1.63. Okay. Number 5, you're going the other way. So that point is root 2, 5 pi over 4. Number 6 is 2, 5 pi over 3. Number 7 is 4, 5 pi over 6. And the last one is 4, 0. Because the radius is 4 and the distance, and then the angle is also this 0. There we go. All right, so today's a pretty short lesson. You guys have a lot of investigation from this, but the goal for today is to be able to graph polar equations. And really a lot of it is stems from the idea that polar equations are points that you connect from 0 to 2 pi for the most part. So let's go ahead and start with something like r equals cosine theta. Now this is a lot for us to think through. So for right now, I want us to just blank out on what is actually happening to the right with this grid. We're just going to evaluate cosine graphs just as quickly as possible, okay? So think about the cosine graph, and we're going to multiply the cosine graph value by 2. So 2 cosine of 0 is 1. So that equals 2. That's not too bad. Now let's think of pi over 6. 2 times pi over 6 is, or cosine of pi over 6 is root 3 over 2, which is root 3. Pi over 4 is what we're going to plug in next. So 2 times cosine of pi over 4, that is root 2 over 2, which is root 2. Let's move to pi over 3. So 2 times cosine of pi over 3 is 1/2, which is 1. It's not too bad. And then at pi over 2, we can start working with 2 times, that's 0, I believe. So that equals 0. Now we do 2 pi over 3, so that's when we get negatives with our x values. So negative 1/2, which is negative 1. 2 times cosine of 3 pi over 4, which is negative root 2 over 2, which is negative root 2. I'm running out of space here. Whoops. 2, 5 pi over 6. If we did that, that's negative root 3 over 2, which is negative root 3. I'm seeing a pattern happen here. Anybody want to guess what the next one is? It should be negative 2. All right. And then if we move to 7 pi over 6, we'll get to the value there. It's negative 3 over 2, which is negative root 3 simplified, to negative 1/2, which is negative 1, 2 times 0, which is 0, 2 times 1/2, which is 1. Then if we plug in 7 pi, oh, am I 1 off? Shoot a monkey. Sorry guys, I got a little excited with how fast I was going there. And this is pretty much wrong for these guys. My bad. All right, here is where we have 2 times negative root 2 over 2, which is negative root 2. That's what I was missing. Then I have 2 times negative 1/2, which is negative 1. 2 times 0, which is 0. 2 times 1/2, which is 1. And then 2 times root 2 over 2, which is root 2. 2 times root 3 over 2, which is root 3. And finally, 2 times 1, which is 2. That was so much fun. Actually, it was awful. But let's go ahead and graph what we saw. So if we're at 0 for our theta, you are going to. So that means we're here. Okay? Then we're going to go to pi over 6, which is somewhere here, and we're going out root 3, which is about there. And then we're at root 2, and then we're at 0. Okay? If we go, or sorry, we're at 1, and we're at 0. At pi over 2, we're at 0. 2 pi over 3, we're at negative 1. Now, that's here, but I'm going the opposite way. So I'm here. Okay? And then if we go to 5 pi over 6, I'm at negative root 3 over 2, or negative root 3, which is this way. And back at the end, we end up with pi and negative 2. So remember, pi is this way, but I'm going the other way to go opposite direction. So that means I'm going over back to here. So what you just did was you made a circle. Circle, 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 circle. A couple things we need to make sure we see that happening. 2 here is the diameter, and always will be for these circles in this form. So anytime you have a number cosine theta, you're going to have a circle that is hugging the x-axis, and just hugging because it's around it. And then it goes out a diameter of 2, and one of the parts is the pole. Now I'm not going to have us do 2 sine theta. The values are different. Let's just do some specific values. Let's do 0. Sine theta is 0. If I plug in 0 for theta, I end up with 0. So I'm actually starting here. Okay? If I plug in a value like pi over 6, I'm going to go, that's, I think, 1/2, that's 1. So that would be here. Actually, no, it's 2 because we're multiplying. Okay, here's the trick, guys. I'm going to go ahead and jump into the trick. 2 is the diameter. Now, the diameter is actually for this one going to be here. Why? Because it is sine. Sine hugs around the y-axis. And it's a circle, so it's going to go out and back around here. So that is our circle. So the connection you need to be able to make is that this value in the front is your diameter. And which angle it's hugging, or which axis it's hugging, is dependent on what you see here, whether you see sine or cosine. So you may wonder, well, what would it be if it was r negative 2 cosine theta? Well, that's a negative x-axis. So I go over here, and I make my circle. Beautiful. And then if I do, what about if it's r equals negative 2 sine theta, Mr. Fincher? Well, if you go down here, you're going to have a circle there. Done. So you can also vary your circle radii, but it's pretty straightforward. I hope you enjoy the investigation that you have ahead of you. You should get the polar investigation out that you got, and enjoy. Have a wonderful time with this, learning about how to graph polar graphs. See you next time.